Periodic classification of elements. So in this chapter we will study why there is a need to classify elements. So in 1800 there were 31 elements, in 1865 there were 65 elements, but at present we have 117 elements, but one element, that is 117, missing out of 118 elements we have, but this element is not at present in the periodic table. Now what happened after the discovery of large number of elements? It was necessary, I am talking about before 1800, so it was necessary to classify them and arrange them in a regular manner in order to their periodic properties. Periodic properties means the physiochemical properties which repeated after the gap of certain elements. This is called periodic properties. So there was need to classify all these elements to understand their periodic properties. So first there were rough classification which was based on the properties, some properties. So some properties means like this one, Antony Lavoisier. So Mr. Antony Lavoisier, how he classified? He classified like in 1789, like metals, gases, earths, non-metals. Okay, so metals are electropositive, these are the electronegative, these are the elements of the whole compounds. There was one more concept based on valencies: monovalent, divalent, trivalent. Okay, but problem was that if some element frequently appeared in more than one class, like hydrogen. Hydrogen is monovalent, sodium also monovalent, hydride is also monovalent, chloride also monovalent. So but property of hydrogen, sodium, hydride all are different to each other. So this classification was not accepted. This is positive, this is positive, this is negative, this is negative, but all are monovalent. So one classification, different properties. So this was not accepted. So after that, Dalton's atomic theory, atomic mass was the fundamental property of the element. This was the one important event in which scientists began to think about the atomic mass of the element. That could be one of the fundamental property. So they started to making the periodic table. What is the periodic table? Periodic table is actually arrangement of elements in order of increasing atomic masses with elements having similar properties in vertical column. This is the actual definition of periodic table that we will see later on. First, how to arrange the element in order to increasing atomic masses. So first attempt, early attempt of classification of elements. So first attempt based on atomic mass of element was given by Mr. Dauvergne, law of triads. So he was first tried to classify the element on basis of mass. So some group of 3 elements, he took the 3 elements called as triads having similar chemical properties. These triads have similar chemical properties. Chemical means boiling point, melting point, all are similar to each other. The atomic mass of the center element is arithmetic mean of the atomic mass of the 2 elements. So center element, mass of the center element is the average of the first 2 elements. You can see here, they are the some group of triads we can see here. So in this way, sodium, potassium, lithium have given here atomic mass. This is, so if you take the sum of first and 3, you will get the mass 23. 23 is the mass of sodium. Similarly, this and this mass, if you divide it, you will get 81.25 mass of bromine. Similarly, for calcium, bromine 88.5, 79.5. So these were the examples for the triads. Okay, but if you see iron, cobalt, nickel, they have nearly same atomic masses, but they are not giving the, say, cobalt, mass of cobalt, more mass of iridium. So they were not giving the average mass of these 3 elements. So in this case, this triad was not accepted. Why? Few elements can be arranged. It is not applicable even the element belong to the same family like osmium, iridium, platinum, ruthenium, rhodium and palladium. So their mass of rhodium, iridium is not matchable with the average of iron and nickel. So this was rejected. So next classification was done by the Chern-Curtis classification. So here I am giving the picture also. So it is actually he is a French geologist, Chern-Curtis. So he was the first person to make use of atomic mass to produce a classification of periodicity. So what he took one vertical cylinder, he draw the lines as a continuous spiral around the metal cylinders with 16 equidistant lines on the surface. Then a helix of 45 degree angle was drawn to the axis was drawn, an element in the increasing order of the atomic mass arranged. Then he observed that which differ from each other in atomic mass of 16. So elements differ means their properties differ after the atomic mass of 16 or its multiple in a vertical line from the center of the spiral. The elements of vertical line nearly shows the nearly the same property. You can see here. So in this way, there the 16 lines are there. So here up to hydrogen to oxygen. So there were 8 elements here. Okay. So here this is the atomic mass of 16. Again, some properties are matching from oxygen. Oxygen he is taking here. Then he is fluorine, sodium, magnesium, and sulfur. Sulfur atomic mass of 32. So 16, 32, 48 like this. He took the atomic mass. Like you can see, and this form was cylindrical. So after if you rotate it, the same element was repeated over here, like this one. So this was he gave the arrangement like this one, circular way. 60, 16 he was dividing. So, but this was not accepted because this was this classification was okay, but this classification was not properly fit for any other element. So this was again rejected. Next was given by Mr. Newland's law of octaves. He gave the concept of law of octaves in 1864. So actually he said that there are 7 musical notes in music. Okay, and every 8th note is similar to the first one, and it is the first one of the next scale. Similarly, Newland stated that the nearly 8th element starting from the given one is the kind of repetition of the first, like the 8th note of the octave wave. So he called this relationship as the law of octaves. You can see here. So from this classification, so lithium to fluorium, so there are how many elements? 7th element. After that 8th element comes. So this is the 8th element. So property of the 8th element, the repetition of the property of the first element. So this 8th element. Similarly, this is the 8th element, this is first element. That's why this is called as law of octaves. These are the octaves which property is similar to the first one. Again, problem comes here. This element is do not work for the all the elements. This is again limited to some of the elements. So we can see here. So this is your some elements are there. Like he made the notes of the music. So this is the 8th element. This is the 8th element. Like this notes that he made. What about the defect of the Newland law of octaves? The defect was that this element could classify up to calcium. After calcium, this was totally rejected. So after every 8th element didn't possess the property similar to that of first one, and the element that were discovered later could not fitted into the octave pattern. So this element was again not accepted. Then one more element comes. One more class came by Lothar Meyer curves in 1866. That is contemporary, same period only. But he used the concept physical properties such as melting point, boiling point, atomic weight, and he made graph like this one: atomic volume versus atomic mass. It is in AMU, this is in centimeter cubes. Okay, so he used the concept atomic volume, that is atomic mass by density. So by using this concept, he draw this value atomic volume like this one, increasing atomic masses. So he saw some of the graphs like this one. Some peaks were there, some minimas were there, peaks were there, sharp peaks, minimas were there, and he named the elements on these peaks. So in this he found that a similar property of the element is occupying similar position. Similar property of the element occupying the similar position. Similar position means that most electropositive metals like alkali metals like lithium, sodium, potassium, rubidium will occupy the top position. You can see lithium, sodium, they are occupying the top peak. They are the top peaks. Less strong electropositive alkaline earth metals like beryllium, magnesium, calcium will be the descending. So beryllium is after this is top peak, second position will be calcium, then strontium. This will be the second element after the top peaks. And third, most electronegative elements like halogen, fluorine, bromine, this will be ascending position before the inert flow. So before the sodium, here will be your halogen, here will be the if this is lithium, halogen is here this side, here this side, here this side. So these are the just ascending position. One this position, this one halogens, this is your most electropositive element, this is the most electronegative element. And the lower positions, descending transition elements occupy the minimum of the curve. Minimum is lowest position. So these are the lowest positions which occupied by the transition elements. So these are the some of the properties found by the Mr. Lothar Meyer. But why it was not accepted? It was not accepted because it lacked the practical utility, as it was difficult to remember the position of the different elements by looking the peaks. So this was not accepted at all.